Hello, saver. Whether you're saving for that trip to the tropics or saving for an emergency, now is the time to take advantage of Wells Fargo's savings options. Wells Fargo offers savings accounts that can help you save towards your goals. So, what are you saving for? Visit a Wells Fargo branch or wellsfargo.com/save to open a savings account today.
Wells Fargo Bank, N.A., member FDIC.
This is SpaceTime, Series 26, Episode 131, for broadcast on the 1st of November 2023. Coming up on SpaceTime, solving the mystery of the Martian core, protecting the Europa Clipper mission from Jupiter's immense radiation belts, and India preparing for its first manned mission into space. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
A new study of data by NASA's Mars InSight lander mission has concluded that the Martian liquid metallic core is both smaller and denser than previously thought, and also that it's surrounded by a layer of molten rock. The findings, reported in the journal Nature, are based on a fresh analysis of Mars quakes recorded by InSight combined with computer simulations. The analysis shows that the average density of the Martian core is significantly lower than that of pure liquid iron. The new observations also show that the Martian core is somewhere around 1,650 to 1,700 kilometers in radius, which is about 50% of the planet's overall radius, and well down from the 1,800 to 1,850 kilometers previously estimated. NASA's Mars InSight lander spent 4 years on the red planet's surface, recording tremors with its seismometer before finally ending its mission in December last year. Now, a new analysis of the recorded Mars quakes combined with the new computer simulations is painting a very different picture of the planet's interior. The key discovery is that sandwiched between Mars's liquid iron alloy core and its solid silicate mantle lies a layer of liquid silicate magma, about 150 kilometers thick. Now, the Earth doesn't have an equivalent completely molten silicate layer like that. The new Martian discovery resolves a mystery that researchers have until now been unable to explain. See, an analysis of Mars quakes has shown that the average density of the Martian core had to be significantly lower than that of pure liquid iron. Earth's core, for example, consists of about 90% iron by mass. Light elements such as sulfur, carbon, oxygen and hydrogen make up the remaining 10%. But initial estimates for the density of the Martian core showed that it was composed of a much larger share of lighter elements, around 20% by mass, and that's not really possible, at least not based on our current understanding of planetary formation scenarios. If the Martian core is smaller than previously thought but still had the same mass, it follows that its density is greater, and that it therefore contains fewer light elements. According to the new calculations, the proportion of light elements dropped to between 9 and 14% by mass. Now that's still somewhat low, but no longer inexplicable in the context of typical planetary formation scenarios. The fact that the Martian core contains a significant amount of light elements indicates that it must have formed very early, possibly when the nascent Sun was still surrounded by its protoplanetary disk from which the light elements could have accumulated into the Martian core. The initial Martian core calculations had all been based on tremors that had occurred in close proximity to the InSight lander. However, in August and September 2021, the seismometer registered 2 quakes on opposite sides of Mars. One of them was caused by a meteorite impact that produced seismic waves that traversed the core, and this allowed scientists to illuminate and study the core. In the case of the earlier Mars quakes, by contrast, the waves were all reflected at the core mantle boundary, providing no real information about the deepest interior of the red planet. As a result of these new observations, the authors were able to determine the density and seismic wave speed of the fluid core up to a depth of about 1,000 kilometers. Supercomputer simulations were then employed to infer the composition of the core. However, when the authors compared the calculated profiles with their measurements based on the InSight seismic data, they found that the probable core composition simply didn't work. At the core mantle boundary, for example, the iron alloy would have contained much more carbon than the core's interior. After a lot of head-scratching, they eventually realized that this region previously considered to be part of the outer liquid iron core wasn't part of the core at all, but instead it was the very deepest part of the mantle. Proof came when the authors found that the density and seismic wave speed, measured and computed in the outermost 150 kilometers of the core, was consistent with those of liquid silicates, the same material that the Martian mantle is composed of, rather than liquid iron. Further analysis of earlier Mars quakes using the new simulation data then confirmed the results. This is SpaceTime. Still to come, protecting NASA's Europa Clipper mission from Jupiter's intense radiation belts, and India preparing for its first manned mission into space. All that and more coming up on SpaceTime. Engineers have just completed the final piece of armour designed to protect NASA's Europa Clipper mission spacecraft from the intense radiation bombardment it's going to suffer during its mission to explore the Jovian ice moon Europa. Europa's icy crust is thought to cover a massive global subsurface ocean containing more water than all the seas on Earth combined. It's an environment which scientists speculate could be habitable. You see, massive gravitational tides caused by Jupiter and its nearby moons are stretching and squeezing tiny Europa, generating heat and keeping the oceans liquid under an icy shell. Scientists speculate that hydrothermal springs could exist on Europa's seafloor, similar to the hydrothermal vents found along Earth's mid-ocean ridges. Now, here on Earth, these mid-ocean ridge vents provide nutrients for an ecosystem teeming with life, but isolated well below the surface. There's no photosynthesis down there, but there is chemosynthesis. It's an ecosystem that exists completely independent of life at the surface. In fact, some scientists speculate it may be here where life on Earth actually began. NASA's Europa Clipper mission, which will launch in a year from now, will try to determine if the same thing could be happening or could have happened in the distant seas of Europa. But to explore the mysterious ice-encrusted world of Europa, the mission will need to endure constant bombardment by radiation and a stream of high-energy particles surrounding Jupiter. In fact, next to the Sun, Jupiter, the largest planet in our solar system, also has the most punishing radiation environment in the solar system. Jupiter's gigantic magnetic field is some 20,000 times stronger than Earth's, and it spins rapidly in time with the planet's 10-hour rotational period. This field captures and accelerates charged particles from Jupiter's space environment, creating powerful radiation belts. And so, like NASA's Juno mission, which is currently exploring Jupiter's composition and evolution, Europa Clipper will also need to protect itself from all that radiation. And like Juno, it'll do so in two ways. Firstly, by flying an orbital trajectory which tries to avoid as much of the Jovian radiation belts as possible. See, when the spacecraft arrives at Jupiter in 2030, Europa Clipper simply won't park in orbit around Europa. Instead, it'll make a series of wide-ranging orbits around Jupiter, moving well away from the planet and its harsh radiation environment for as long as possible. These highly elongated looping orbits will then swoop down around Europa, spending as little time in the danger zone as possible. And it will do this nearly 50 times to gather enough scientific data. Now, the second part of the radiation protection process, again, like Juno, involves placing the probe's delicate electronics in a special armor-plated sealed vault. And Europa Clipper's engineers at NASA's Jet Propulsion Laboratory in Pasadena, California, have just sealed that vault with the electronics inside. Europa Clipper's Deputy Flight System Engineer Kendra Short from JPL says closing the vault is a major milestone in the mission. It means everything's in there that has to be in there and it's all functioning properly. The 1 centimetre thick aluminum vault houses the sophisticated electronics for the spacecraft's suite of science instruments. The alternative, shielding each set of electronic components individually, would have added not just cost but also immense weight to the spacecraft. JPL planetary scientist Tom Nordheim says the Jovian radiation belts are so intense that scientists believe it modifies the surface of Europa, causing a visible colour change. In fact, the radiation on the surface of Europa really is a major geologic modification process. Nordheim says Europa's reddish-brown colour is caused by consistent radiation processing. Once Europa Clipper arrives at its destination, Nordheim will zero in on the frozen world's chaotic terrain areas, places where blocks of surface material appear to have broken apart, rotated and moved into new positions, in many cases preserving pre-existing linear fractures and patterns. Some areas of Europa's surface show evidence of material transport from the subsurface using plumes and cryovolcanism. Nordheim says scientists need to understand the context of how radiation modified that material. Radiation can alter the chemical makeup of material. Because Europa's oceans are locked inside an envelope of ice, any possible life forms that might exist in those seas wouldn't be able to directly rely on sunlight for energy as plants do here on Earth. Instead, like the ecosystems around Earth's mid-ocean ridges, they'd need alternative energy sources, such as heat and chemical energy. But radiation raining down on Europa's surface could also help provide such a resource by creating oxidants, such as oxygen and hydrogen peroxide, as the radiation interacts with the surface ice layer. Over time, these oxidants might be transported from the surface down into the oceans below through this chaotic terrain. So in this way, scientists could use the European surface as a window on its subsurface. Europa Clipper's main science goals are to determine whether there are places below the Moon's icy surface that could support life, determining the thickness of the Moon's icy shell, its surface interactions with the ocean below, and to investigate its composition and characterize its geology. This report from NASA TV.
NASA's Europa Clipper will explore an icy moon of Jupiter to see if there are conditions that could support life. Let's head into the spacecraft assembly facility behind me to see how the mission is coming together. I'm Raquel Villanueva, here today with Jordan Evans and Trina Ray. Before we can head inside, there is one more step we need to take.
We have to gown up. We have to protect the spacecraft from us, all the particles that might fall off of us. So to cover our hair, we have to not wear makeup, no perfume. The Europa Clipper mission is a spacecraft that we're sending out of the Jupiter system. It's going to orbit Jupiter, but fly by the moon Europa. And it's a moon that is, we think, has an ocean underneath. And we want to investigate that.
We'll be in this room until we ship to the Kennedy Space Center for our launch campaign in the late spring of next year, 2024. During that time, it'll make a couple of trips out of this building for testing.
We have so many questions about Europa. We have an icy crust with an ocean underneath. And the water that's in that ocean has been sort of, churning and stewing for like 4 billion years. And so we've got a lot of questions to try to answer about the interior or about the geology or about the composition.
To answer those scientific questions, obviously we have to get to Europa first. So one of the key elements of the spacecraft design is being able to bolt the spacecraft onto the rocket. That'll give us the energy we need to get to Jupiter. And then once we're at Jupiter, being able to generate electric power and accommodate our very large solar panels and our very large high-gain antenna to send that science data back to Earth. And all of that has to be done with materials that are safe for the immense radiation environment at Europa. Starting at the far end, that's the interface to the launch vehicle. That's where we bolt Europa Clipper to the Falcon Heavy rocket. And from there, inside there are our propulsion tanks, some sensitive communications electronics where our large high-gain antenna mounts. There's some paper on the outside, and those are actually patterns for the sewing that's required on our thermal blankets. Thermal blankets with the right optical properties to maintain the temperatures of the vehicle, as well as provide protection from micrometeoroids.
Trina, can you kind of tell us more about the instruments?
We don't have all of our instruments on board yet, but what we do have are 3 of our cameras. We have cameras that operate in the visible. We have cameras that operate in the infrared, cameras that operate in the ultraviolet. Those all look at Europa at the same time, just in different wavelengths. But then we also have a thermal imager. So think of that as like the night vision goggles, right? So what you're looking for there is a thermal signature. So imagine you have this ocean and it's churning away and it makes the ice right above it a little bit warm. And so the thermal imager will be able to tell you that.
And seeing the spacecraft up close, I just want to know, what does this mission mean to the both of you?
It represents the hundreds of thousands, the millions of hours of the dedicated engineers and technicians and scientists.
I treasure my job every day. I come to work and I'm like, we're going to do our part. We're going to answer these questions, but we're going to ask the next questions for the next generation to be inspired and to build their spacecraft and go.
This is Space Time. Still to come, India continues with preparations to launch its first manned mission into space. And later in the science report, a new study warns that future increases in ice shelf melting in the West Antarctic are now potentially unavoidable. All that and more still to come on Space Time. India's carried out a successful test flight of a mock-up of its new manned capsule, which will ultimately transport the subcontinent's first astronauts into orbit in 2025. The 10-minute Test Vehicle Demonstration 1 mission by the Indian Space Research Organisation ISRO involved launching a crew module mock-up from the Sriharikota Space Centre on the Bay of Bengal coast aboard a GSLV L-40 rocket and then bringing it back to Earth, testing the spacecraft's crew escape system. The mock-up Gaganyaan or Skycraft capsule separated from the launch vehicle just as planned, and then safely splashed down under parachutes into the sea before being picked up by the Indian Navy and returned to land. The launch had been delayed by several hours due to weather conditions and a glitch with the rocket's main engines. ISRO expects to conduct some 20 test flights of the new spacecraft, one carrying a robot, before the first human flights are undertaken in 2 years' time. That first manned flight will be a 3-day orbital mission carrying a crew of 3. India's also announced plans to develop its own space station by 2035 and place a man on the moon by 2040. This is Space Time. And time now to take another brief look at some of the other stories making news in science this week with a science report. A new study warns that future increases in ice shelf melting in the West Antarctic are now potentially unavoidable. The findings, reported in the journal Nature Climate Change, mean the melt will cause sea levels to rise. The researchers looked at a computer simulation of the interactions between ice and oceans under various emission scenarios. They say it's now likely that ocean warming in the region is already locked in at about triple historic rates. The findings mean that some degree of sea level rise is also now locked in, but more research is needed to fully understand exactly how much the West Antarctic ice sheet will contribute. See, the ice sheet's already floating on water, so the displacement shouldn't make much difference. But as the ice sheet melts, it allows more glacial ice from land to flow down into the sea. The authors say the West Antarctic ice sheet is the largest, but not the only contributor to sea level rise, and other ice sheets may respond differently to climate change. Vegetarianism may be partly related to your genes, according to a new international study of more than 33,000 genomes. The study indicated 34 genes potentially are involved with vegetarianism. The findings, reported in the journal PLOS One, compared genomes from 5,324 strict vegetarians to 329,455 non-vegetarians, and identified 34 genes that may contribute to choosing to have a vegetarian diet. The authors found that several of these genes have important functions in lipid metabolism and brain function. This raises the possibility that differences in how the body processes lipids and the resulting effects on the human brain may influence whether someone's willing or even able to choose a vegetarian diet. A new study has shown that the now arid zone of the eastern Mediterranean was once a region of green savannas and grasslands that provided an ideal passage for multiple early human movements out of Africa. The findings, reported in the journal Science Advances, supports the growing consensus for a well-watered Jordan Rift Valley that funneled human migration into Western Asia and Northern Arabia. The present harsh environment of the Levant and Arabia are the key regions through which early hominids, the genus Homo, including Homo sapiens, had to pass through when leaving Africa and moving to Eurasia between 129 and 71,000 years ago. Scientists successfully integrated the chronometric data along with paleoclimatic records to examine this corridor. The record is associated with the formation of the paleo-wetlands, which is associated with stone tools that have been found in the area, some dating back some 84,000 years. New super smart AI chips by Qualcomm, Opta shows how to make your house smarter, and the iconic iPod turns 22. With the details on those stories and more, we're joined by technology editor Alex Zaharov-Reutt from TechAdvice.life.
Yeah, they're talking about how the AI component is 98% faster with 40% more efficiency. If you ask it, for example, to make an image using stable diffusion where you just type in something in text and you get it to then create a photograph or an oil painting or some sort of image, that would have taken 15 seconds to create the image with last year's chip. This year's chip is a fraction of a second to do that. You can actually have a large language model running 10 billion parameters running directly on the phone itself. So instead of needing a data center, as is the case with ChatGPT, you'll be able to have your device running these large language models to answer pretty much any question. And you can sort of think of it in terms of the Hitchhiker's Guide to the Galaxy, the book, the electronic book that Douglas Adams wrote about. He prophesized in his excellent science fiction story. And in the past, we would have imagined that that would have simply have been like a database, like a giant phone book of information, like an encyclopedia. But with these large language models, you can actually have the AI reason and come up with examples of how to do things just because it's got so much information inside of it. And by the same token, Qualcomm has also been working very hard to make a chip that runs in a computer that can run Windows that has the same sort of advantages that Apple launched with its M-series chips, where it's taken a smartphone chip, a tablet chip, and it's super powered it. Qualcomm was saying at its event that its chip, the Snapdragon X series, is faster and more power efficient than the Apple M2 Max, which is one of the more powerful chips. Not as good as the M2 Ultra, but still pretty powerful chip. And also it is more powerful than the current Intel 13th generation top-of-the-line chip with 70% lower energy usage. Now, the catch here is that what Qualcomm says and what it delivers is something we're all yet to see. Its previous powered chips for running the desktop version of Windows were underpowered, couldn't match what the Intel or AMD chips were doing. But they're promising a lot. The only other catch is that it's not going to be available until the middle of 2024, and Apple is coming out with their Scary Fast event, that's the name of it, and it looks as though, it hasn't been confirmed yet, but it looks as though they're going to launch M3 plus processors. They had the M1 and the M2, and this will make whatever Qualcomm has got be, once again, a generation behind.
Optus are hoping to turn your whole house smart with their latest offerings. What are they up to?
Yeah, they say that 8.9 million homes in Australia already have some sort of smart home technology inside, but what they're trying to do is get people to learn about smart home technologies, to use them and to benefit from them. And so this could be where you've got somebody who's sitting at home and the doorbell rings and they're watching Apple TV, and bang, in the top right-hand corner, you see a picture of who's there and you can get live captions of what they're saying. You can use the smart switches. You can have appliances in your kitchen, all over the home.
Yeah, I don't want my fridge knowing what I've been munching on, quite frankly.
Well, look, it's up to you which smart technologies you use. But not only are they able to sell them to you, whether you're an Optus customer or not, but they also have the O team, O obviously being the O for Optus. But this is a push to get people understanding and using smart home technology.
I realised how old I was when I saw that. The iPod has just turned 22.
Yes, 22 years in October 2001. That's when the first iPod was launched with the click wheel. In fact, at the time, it was a physically moving wheel.
Well.
Yeah, it wasn't until later that it became touch sensitive. But that little player could put 1,000 songs in your pocket. And look, there were other MP3 players around at the time. They needed the equivalent of SD cards at the time, and there was one from Creative, the company that was well known for the Sound Blaster sound cards. Not that you hear much about that anymore, but they had a CD, a Walkman-sized device, which had a hard disk and which could transfer songs wirelessly. And one of the reviews on Reddit was saying, "Oh, lame, less space than a Nomad, no wireless, lame." But it's what propelled Apple into the multi-trillion-dollar company that it is today. Took them away from just being known as a computer company and being known as a consumer electronics company. And it's the grandfather to all the iPhones and iPods and tablets and the Macs that we have today that are using what were originally the same sort of chips that were in those iPods.
And what else is on the website this week?
Amazon is making it easier to use passkeys. There's news about the Australian streaming market. Apple's event that's coming up very soon with the new Macs, NVIDIA getting into the chip-making business, artists figuring out how they can protect themselves from AI, and plenty more. So please come to techadvice.life and check it out.
That's Alex Zaharov-Reutt from techadvice.life. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more space time, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.